Is quantum computing truly the future of technology, or is it an overhyped dream that's destined to disappoint? This question is at the heart of our exploration today. Quantum computing, a field as enigmatic as it is promising, finds itself in a paradoxical state. On one hand, it teases us with the tantalizing prospect of revolutionizing the tech world. On the other, it looms with skepticism and doubt, often leaving us in a cycle of anticipation and disappointment. A recent article on Wired.com encapsulates this sentiment quite aptly. It presents quantum computing as a Schrödinger's cat of sorts, simultaneously brimming with potential and teetering on the edge of failure. It's a peculiar situation, one that's both exciting and frustrating for those in the field. So where does this leave us? Well, it sets the stage for a thrilling exploration. This paradox, where quantum computing seems both poised for breakthrough and teetering on the edge of failure, sets the stage for our journey into the history and future of quantum computing. To understand where we are, we need to look at where we've been. The history of quantum computing is a fascinating tale of innovation and setbacks. The story begins in the early 20th century, when quantum mechanics was in its infancy. Theoretical physicists like Erwin Schrödinger were laying the groundwork for what would eventually become quantum computing. Schrödinger's infamous cat, both alive and dead until observed, is a perfect analogy for the quantum bit, or qubit, the basic unit of quantum information. Fast forward to the late 20th century, when the first ideas for a quantum computer were being proposed. Quantum computing took a giant leap forward in the 90s, with the development of quantum algorithms like Shor's algorithm for factorizing large numbers. This was the dawn of a new era, where the power of quantum computing began to be truly realized. But the journey hasn't been smooth sailing. Quantum computers are incredibly sensitive machines, prone to errors from even the smallest environmental interference. Efforts to scale up these machines have been met with significant challenges. And then there's quantum supremacy, the milestone of a quantum computer outperforming a classical one. It's been claimed, disputed, and remains a hot topic of debate. While the road has been rocky, the progress made in quantum computing is undeniable. Yet the question remains, what's next? So where does the field of quantum computing go from here? Is it destined to revolutionize technology or fade into obscurity? This is the question that keeps scientists, engineers, and tech enthusiasts alike awake at night. The future of quantum computing is as uncertain as the quantum states it tries to harness. On one hand, the optimists envision a world where quantum computers solve problems that are currently impossible for classical computers. They speak of breakthroughs in cryptography, drug discovery, and even climate modeling, all powered by quantum mechanics. But on the other hand, the skeptics remind us of the monumental challenges that stand in the way. They point to issues like quantum decoherence, where quantum information is lost to the environment, and the sheer difficulty of building and maintaining a quantum computer. And let's not forget the paradox we introduced in the first scene. Quantum computing is a field where promise and disappointment are two sides of the same coin. It's a field that's been declared dead and revived more times than Schrödinger's cat. So what will the future bring? Will quantum computers live up to the hype and revolutionize our world? Or will they remain an elusive dream, always just out of reach? Whether quantum computing will become the future of technology or an overhyped dream, only time will tell. But one thing's for sure, it's a field worth keeping an eye on.